Welcome to the class. Dear students, today we are going to discuss benzoin condensation. So in benzoin condensation, what we are going to see is which compound shows benzoin condensation, what is the reaction, what is the product of the reaction, and mechanism, how many steps are there in mechanism, and what is the significance of benzoin condensation. All this we are going to see in this video class, benzoin condensation. Let us start. Benzoin condensation, it is a reaction that is shown by aromatic aldehyde. It is a reaction that is shown by aromatic aldehyde. Okay, so only aromatic aldehyde shows benzoin condensation. No other compound in organic chemistry shows benzoin condensation. It is only aromatic aldehyde that shows benzoin condensation. So what happens in this is that two aromatic aldehydes, okay, here I have taken benzaldehyde, it can be any aromatic aldehyde. Two aromatic aldehyde, they react with each other. They undergo self-addition in the presence of KCN in aqueous ethanol. In the presence of KCN in aqueous ethanol to produce alpha hydroxy ketone. Why alpha? See, this is the functional group here. This is alpha carbon atom. Alpha hydroxy ketone. Okay. So we have used the simplest of all aromatic aldehydes. The simplest of aromatic aldehyde is benzaldehyde, and we got alpha hydroxy ketone here. This alpha hydroxy ketone, this one particular, its common name is benzoin. Okay. So therefore other aldehydes are derivatives of benzoin. So therefore this reaction is called as benzoin condensation. Therefore the reaction is called as benzoin condensation. So let me repeat what I have repeated. It is shown by aromatic aldehyde, point number 1. Okay. Two aromatic aldehydes, they undergo self-addition reaction in the presence of KCS in aqueous ethanol to produce alpha hydroxy ketone. This is alpha carbon atom, alpha hydroxy ketone. But because we have used benzaldehyde, we have got an alpha hydroxy ketone whose common name is benzoin. Others are other aldehydes are derivatives of benzaldehyde, so they will be derivatives of benzoin. Correct? So this is called as benzoin condensation. Now a question comes to our mind as to why we have used KCN in ethanolic water, because only one was fine to solvate it. There are two purposes of using this mixture, ethanol water. One, to solvate this salt KCN, and second is to get the nucleophile. The nucleophile is Cn minus. The reaction is nucleophilic addition reaction. The mechanism of this reaction is nucleophilic addition reaction. The first nucleophile is Cn minus. So we need to take that Cn minus out of this system. So therefore we are using this. What happens is ethanol, it combines with H2O and H plus is eliminated. Right? It is acidic compared to water. Okay. So C2H5 comes out. C2H5 is a very strong base. Okay. It is an alkoxide ion. It's very strong base. So what happens? It takes K plus. Okay. And Cn minus is released into the system. So that is why we are using this mixture, C2H5OH and H2O. Okay. Two reasons. One, it effectively solvates the solute molecule, the salt. It effectively solvates through hydrogen bonding. Okay, it both can show hydrogen bonding to KCN. So it effectively solvates KCN. Not only that, it releases Cn minus into the system. How it releases? This is shown in the reaction. Correct? So that is what our purpose is. That is to release Cn minus. Now let us discuss the mechanism of benzoin condensation. So as I have already mentioned that the mechanism is nucleophilic addition reaction. So which is the nucleophile here? Cn minus. How is Cn minus released into the system? We have already seen. For that we are using ethanol water mixture, and when ethanol water mixture is used, it implies that the KCN does not exist as salt, that KCN exists as ions. Correct? In this mixture, KCN exists as ions. K plus is the K plus is the spectator ion and Cn minus is the participating ion in this reaction. So we will see now in mechanism how it participates. So this is mechanism. Mechanism is nucleophilic addition reaction. Nucleophilic addition reaction. We will see how reaction. There are 3 steps for this mechanism. Step number 1, formation of carbonium ion. Formation of carbonium ion or simply carbon ion. Carbon ion. Let's look at the first step. So here is our correct first aldehyde. Already there is Cn minus in the system, correct, because KCN in aqueous ethanol, it will release Cn minus into the system. How? We have seen it already. Now look at this, there is already a rift between carbon and oxygen. Oxygen is electronegative and carbon is electropositive. So the electron cloud will be deviated towards electronegative oxygen and it will be deviated away from electropositive carbon. Now the Cn minus, it can come and attack at this position, and what we get is this. Am I right? Now what would happen? This is very unstable and it attracts the proton from here. The proton gets attached here, and what we get is this. Right? When the proton goes and attacks this electron pair, this pair of electron is left with the carbon, and therefore we are telling carbon anion. We are referring carbon anion to this structure. Okay, this is the carbonium ion or carbon anion. So we have formed carbon anion in the first step. Okay, let us now go to step number 2. Do you think the carbon anion will remain like that without doing anything, idle? Will it remain idle in the system? No. What it will do? It will attack the second benzaldehyde molecule, right? So the second step is attack of carbon anion. Carbon anion. Let us see how it attacks. This structure, let me write it here. So I have written this structure. This is the structure. Let me rub this. There are 2 molecules of benzaldehyde. This is the second molecule. Okay, this is benzaldehyde second molecule. As already I have said, this is a very polar molecule. A dipole exists between electropositive carbon and electronegative oxygen. With the result, the electron cloud is shifted away from carbon towards oxygen, and therefore this is negative, this is positive. Okay, now what would happen? Yes, you guessed it right. This electron pair will go to oxygen and this will become completely positive and attached to this carbon anion. So the result is like this. So we get this molecule here. Am I right? Yes, we get this. Now we have seen now what happens. This carbon anion molecule attacks another molecule of benzaldehyde. The benzaldehyde has a rift within it. It is a dipole. There is a dipole within the molecule, and in this battle oxygen wins and oxygen gets the electron pair. Carbon gets positive charge. The positively charged carbon now combines to negatively charged carbon to give this molecule. Let us go to step number 3. Step 3, proton shift. Proton shift and loss of Cn minus. Let us see what does it mean. I am going to draw this molecule here. So this is the molecule, this is the product of second step. So here we go. So we have drawn the molecule of the second step here. Okay. Now what would happen? This H, it would go here and combine here because this is very unstable. So this H would go and combine here and we get a molecule like this. Right? Now what would happen? Now we got a molecule like this. Now what would happen? This electron pair, it is unstable here. It would try to make a pi bond with carbon. When it tries to make the pi bond with carbon, carbon would become unstable. Its valency is only 4. So this Cn minus gets eliminated out. And with the result, the molecule that we get is nothing but a alpha hydroxy ketone or benzoin, right? Which is the alpha carbon atom? This one, alpha hydroxy ketone. Okay, in reaction we have shown it like this. Okay, don't get confused. If you want, I will draw like this. In the reaction we have shown like this. Okay, so don't get confused. I am just reversing the molecule. Correct? Alpha, which is alpha? This one. Alpha, this is the functional group. Alpha hydroxy ketone or benzoin. So these are the 3 steps. Step number 1 is your formation of carbon anion. Step number 2 is attack of carbon anion. What does that carbon anion attack at? It attacks at the carbonyl carbon of the second benzaldehyde molecule. And the third step is proton shift and loss of Cn minus. After that, after this step is over, we get our final product, which is benzoin or alpha hydroxy ketone. Okay, the common name is benzoin. If you are using higher aldehydes, you will get higher benzoin derivatives. Correct? Okay. Now let us understand the significance of this reaction. What is the importance of benzoin? Let us understand that. If we are making benzoin, what is our advantage? What benefit it is to us? Let us understand that. So this is benzoin. So we can make from benzoin, we can make benzyl. We can make benzyl. Benzyl structure is like this. So we see, this is benzyl. So what we have done here is we have oxidized benzene. Benzoin we have oxidized. Okay, we have used conc HNO3. There is a reaction in one of our semesters in B Pharm, preparation of benzyl from benzoin. This is benzyl. So what we are doing in that reaction is we are taking this benzoin in a RBF and we are reflexing it with the conc HNO3 for 2 hours. After reflexing for 2 hours, the solution that we get, we pour it in cold water. When we pour it in cold water, we get a pale yellow product. That product is benzyl. So what is the benefit of producing benzyl? See, from benzyl we can make 3 drugs. Pharma industry makes 3 drugs from benzyl. The first drug is phenytoin. Phenytoin. So it is a precursor for phenytoin. Do you know the use of phenytoin? Phenytoin is used as anti-epileptic drug. Okay, in epilepsy we use phenytoin. It is used in tonic-clonic seizure, in grand mal epilepsy, in status epilepticus and in complex partial seizures. So phenytoin is very important drug as far as the prevention of epileptic attack is concerned. The second drug which is made using benzyl is clidinium. Clidinium, it is a anticholinergic drug. Clidinium is anticholinergic drug. it reduces the gastric acid. It reduces gastric acid. It also brings down the spasms of the bowel. Okay, it reduces the spasms of bowel, it reduces gastric acid secretion, and it brings relief. Okay, for those people who are suffering from ulcerative colitis or peptic ulcer, clydenium will bring relief by bringing down bowel spasms as well as by bringing down the acid secretion. So from benzyl we can make clydenium. The third drug that we make using benzyl is flurtropium. Flurtropium. Now what is flurtropium used as? It is a muscarinic antagonist used in the symptomatic treatment of asthma and COPD. Okay, chronic obstructive pulmonary disease. So it can bring relief in symptoms of asthma. It can bring relief in the symptoms of COPD. Okay, so these are the three drugs which are made by the pharma industry using benzyl as the precursor. And how is benzyl made? From benzoin. And how is benzoin made? From benzoin condensation. So that much is the importance of benzoin condensation, that we can indirectly make three drugs that is marketed by the pharma industry. Okay, so that is the first significance. Let us now look at second significance of your benzoin. So if you are going for reduction, partial reduction, not complete, if you are going for partial reduction of benzoin, what do you get? Let us see that. So if you are going, I am writing it as C6H5, or otherwise no issue, I will write it like this only. Okay, so what you get if you are going for partial reduction, let us see. So this is the product that you get. This is deoxybenzoin. Deoxybenzoin. Okay, so deoxybenzoin, it is a photoinitiator. It is a photoinitiator for vinyl polymerization. It is a photoinitiator for vinyl polymerization. Vinyl polymerization. What does it mean? What is a photoinitiator means? Photoinitiator means, this is a photoinitiator. What is a photoinitiator means? Photoinitiator means that this molecule, it acts as a source of free radicals, it acts as a source of cations, it acts as a source of anions. Free radical, it may act as a source of free radical in free radical polymerization reaction. It may act as a source of cation in cationic polymerization. It may act as a source of anion in anionic polymerization. So what photoinitiator means is that this molecule acts as a source of free radical, anion or cation. Okay, and that would initiate, or that would start the polymerization reaction, okay, in vinyl substrates. So that is the importance of deoxybenzoin. Okay, that is prepared by partial reduction of benzoin. Okay, now if you are going for full reduction, complete reduction, then you get another compound that is like this. This is stilbene. Stilbene are used as dyes. It is used as dyes. There is a very famous example and very popular example of stilbene, resveratrol. So resveratrol, you know, it is found in the skin of the grapes, and it is a kind of dye. So stilbene, some of the stilbenes are having dyeing properties. Okay, there are many stilbenes, there are many derivatives of stilbenes. Stilbene is a family of compounds. So some stilbenes, they act as dyes. Some stilbenes, there are other substances. For example, diamine stilbene. Diamine stilbene, it acts as whitener. Okay, it has scintillating property. So it brings upon optical brightness, okay, to clothes or to whatever you apply it on. So therefore, diamine stilbene, it is used in laundry detergents. Diamine stilbene, it is used in laundry detergents. Why? Because it has a property of scintillation, or it has a property of bringing optical brightness on clothes. So you can say that benzoin is a very important precursor for optical brightness producers in laundry detergents. So this is the significance of benzoin. From benzoin we can make three things. If you are oxidizing benzoin, you can make benzyl, and benzyl we know it is a precursor of three drugs: phenytoin, clidinium and flowtropium. If you are partial reduction of benzoin, that would produce deoxybenzoin. It is acting as a photoinitiator. Okay, it acts as a source of free radicals in polymerization reaction. Okay, and if you are complete reduction, then you will get stilbene. Stilbene is used as dyes, and it is used in laundry detergents for producing brightness to clothes. Dear students, I hope you have understood the class, and I hope you have liked it. If you have done so, if you have understood and liked the class, please do not forget to subscribe this channel. Please do like it and share it with your friends. Thank you very much.